boys and girls, welcome to 6th grade physical science, and today's standard is P.6.6.6, which states investigate forces acting on objects, use data to explain the differences between the forces in various environments. And they just list a few examples like airplanes or bicycle helmets, or I could really have picked anything, and I decided to stick with airplanes for this particular standard. So in today's lesson, we're going to focus on these four forces and how they impact the movement of an airplane. And those forces are friction, drag, lift, thrust. And if you look at the image I have from NASA of the airplane, it has it labeled where you're going to experience these four different forces with an airplane. So before we start this, let's go over each of these words and define them. And we're going to talk specifically with or how these apply to airplanes. So friction is the resistance of motion when one object rubs against another. Anytime two objects rub against each other, they cause friction. And we're going to be talking about a fluid friction, air resistance, as that is friction moving over the surface of the airplane. Drag is also known as air resistance. It's also known as drag. It's a force that is caused by air. The force acts in the opposite direction to an object moving through the air. Lift is a force that is directly opposes the weight of an airplane and holds the airplane in the air. And then thrust is the force which moves an aircraft through the air. So let's talk about friction in airplanes. Air friction is experienced by objects moving through the open air. Air friction acts between the objects and the air through which it is moving. It is also called drag. This force depends upon the object's shape, material, speed with which it is moving, and the viscosity of the fluid. So if you remember, air is made up of all these tiny little particles, little molecules of elements like hydrogen and helium and oxygen and carbon. And so that's matter, and they are taking up space. And those little atoms are causing a type of friction over the surface of the airplane. Drag in airplanes. Drag is the force which delays or slows the forward motion of an airplane through the air. It is the friction of the air as it meets and passes over and about an airplane and its components. The more surface area exposed to rushing air, the greater the drag. An airplane's streamlined shape helps it pass through the air more easily. Drag is created by the force of air particles striking and flowing around the airplane, and it is overcome through thrust. If you've ever tried running or riding a bike into a strong headwind, then you have directly experienced how hard drag can be to overcome at times. In the case of riding a bicycle, you can create thrust by pedaling. So maybe you've experienced that before, playing outside and you're trying to run, but you've got the wind going against you. Then you've been experiencing drag, and you have to overcome that by pushing harder with your feet against the ground to apply more force to move your body. Okay, lift in airplanes. An airplane's wings are designed to take advantage of lift. They are shaped so that the air has to travel further over the top of the wing than underneath it. When the air has to travel further over the top of the airplane wing, it must also travel faster, which results in lower pressure. The shorter distance under the wings results in higher pressure, causing the airplane to move upward. Thrust in airplanes. Thrust is the force needed to overcome the resistance of air, or drag, to the passage of an aircraft. To maintain level flight at a constant speed, constant thrust is required to climb or descend the aircraft while it's maintaining constant speed. The thrust must be increased or decreased. To increase or reduce the speed of the aircraft while maintaining level flight, the thrust must be increased or decreased. So we're talking full throttle power of the engines here, and maintaining the aircraft to overcome that drag or that resistance that we've mentioned with the types of friction. Flight forces. The same principles of balanced and unbalanced forces apply to forces affecting flight. To begin, a wing generates lift because the air goes faster over the top, created an area of low pressure that is an upward force. The weight of the plane is the force of gravity pulling down in the opposite direction of the lift. The thrust comes from the plane's engine, sending out jet exhaust in one direction, which causes the plane to thrust forward in the opposite direction. That's Newton's third law of motion, if you think back to that. Air friction rubbing against the body of the airplane creates drag in the opposite direction of the thrust. If the plane goes fast enough to get lift to overcome gravity and drag, then the net force will be forward airspeed. And that's directly relating to Newton's second law of motion. Force equals mass times acceleration. So for me, the best way for you to practice this and learn this and understand these principles is to build it. So you're going to put into practice what we've just discussed, these four forces. You are going to need a sheet of paper, you're going to need a pencil, and scissors will be optional. There's a few key questions that we're going to try to address with this activity. Number one, in which directions would forces act on a plane while it's in flight? Number two, what causes these forces? Number three, how is thrust created in an aircraft and then in your paper plane? Number four, to speed up the plane, which force would you increase? Number five, to get the plane to climb, which force would you increase? And number six, which of the forces are due to natural phenomenon and which are artificially created? So which ones occur when you go to launch your paper airplane and that you see take place? And then which ones are created by you based on the design and the shape and the amount of force you applied to your paper airplane? So what do you need to do? Well, to start off, you're going to make a basic paper airplane and then you're going to fly it. I want you to take that paper airplane, I want you to fly it around your house or fly it in the hallway and watch what happens. Then I want you to draw arrows on that paper airplane. And if you go all the way back to the beginning of the video, you are going to see where I had a picture of the airplane and I had labeled all four of those forces to help give you an idea of where to put those arrows. And then I suggest doing this with a parent or a friend, and you guys work together and you can compare where you placed your arrows. That's number three. Number four, discuss with your partner the forces that you've identified and whether those forces are thrust, drag, lift, or gravity. And then have a discussion. So what you really need to do is make your own paper airplanes. And I just put a few cool designs that I found that I liked of types of paper airplanes. And I suggest making more than one. I have a picture here with the different forces labeled as well on this model. But build a few and run some tests on them and decide which things have you learned about drag, lift, gravity, and thrust, and which airplanes maybe have more drag, which airplanes get a better lift, which airplanes seem to be more affected by gravity, and then which airplanes can you increase or decrease the thrust to get it to travel different distances with success. So try this out and apply these forces that we've discussed.